Good afternoon. Today we are doing section 3.4, estimating sums and differences. You notice that I put a page number up here just to give you some extra examples to try to help you through estimating sums and differences. There's going to be 3 different ways that we estimate. The first way is to use rounding. So we estimate by rounding each decimal to the nearest whole number. Now remember, a whole number is any number in front of the decimal place. This is easy to use, or easy for you to add or subtract mentally. Okay, so when we change them to a whole number, we want it to be numbers that are compatible, numbers that we find are easy to add. So you look at our example. The whole number here will be to the ones column. All right. So I have 1524. If I look back at the 2, I know I'm going to keep it as 15, okay, because it's below 5. So it's going to stay the same, so that changes to 15. For 32, I look back at the 1, and once again, it's below 5, so I'm going to keep it as 2. So I have 15 plus 32, which is 47. So that's rounding. Once again, you're rounding to the nearest whole number. When we use clustering, we estimate by rounding a group of close add-ins, so close numbers that all add together, to the same number. It has to be the same. Okay, then we're going to multiply, and the reason we multiply is because I'm adding numbers that are all the same to one another. It's the same as just multiplying them by the numbers. And since we're really good at our multiplication facts, it just saves us a step. Okay, so I have 5.32, 4.78, and 5.42. And sometimes you'll have a number that's a lot larger or a lot smaller than the rest, but you're going to go with the most common number. And our most common number here is to change all of these to 5. So I could do 5 plus 5 plus 5, or I could take 5 times 3 because there are 3 5s. And that's how I get the 15. For front-end estimation, you estimate by adding or subtracting the values of the digits in the front place or frontmost places. Okay, so I'm going to estimate to, my 1 and my 5, and it's 109.4, so it's easy just to change that to 100. And 5 or 513.8, it's easy to change to 500. So I'm just going to do front end, which means the front number should be the only non-zero number. Okay, 100 plus 500 is 600, and that's how we do front end estimation. It's going to be smart for you to keep referring back to these examples or to use your book, those page numbers that I gave you in the beginning. So we're going to start by rounding. And if you recall, when you round to the nearest whole number. And your whole numbers are the numbers in front of the decimal places. Okay, so I have a 49, so it's a 9. I look back at the 5, so I should round this up to 50. Plus, then I have 16. Now when I look back at the 2, I know I'm going to keep it the same. So I have 50 plus 16. This is easy for us to add in our head, and the answer is 66. So once again, rounding to the nearest whole number. For B, why don't you go ahead and pause it and see if you get the same answer as me. So once again, what you're going to do is I'm rounding to the nearest whole number. So I look back, and it's a 6, so I can round up to 63 minus. I look over at the 3, I look back at the 0, so I'm going to keep it the same because it's less than 5. So I get 13. And once again, these are easy numbers that I can subtract. I know 63 minus 13 is 50. Get my pen to work here. And there's my solution. So once again, when you're rounding, you're going to round to the nearest whole number, the number in front of the decimal. Okay, for clustering. Remember, the trick for clustering is to change them all to the same whole number. Okay, so if you look at all of these numbers, I have 6.99, 6.59, 7.02, 7.44. You notice they're either all above or below 7. So the closest number to all 4 of these, it has to be collectively through all the numbers, is going to be 7. So once again, you can just add all your 7s, or you know it's the same as 7 times 4, and your solution is 28. Okay, I want you to once again try to pause it and see if you can get this next answer, and then press play and see if you get the same answer as me. So once again, we want to change it to the same number. So you'll notice that they're either above or below the whole number 5. So I'm going to change them all to 5s. And once again, I can add them, or I have the option of multiplying. 5 times 3, because there are 3 5s. And that solution is 15. So that's clustering. Now I just want to add something extra in here. Say you have 5.99 as well. Okay, this is closer to 6, but everything else, all my other 3 numbers are closer to 5. So what you're going to have to do, even though it's closer to 6, is we're not going to worry about it. When we cluster, when they want us to cluster, you're changing them all to the same whole number. So I would change this to a 5 as well. Okay, and majority is going to rule here. So if you have 4 numbers that are closest to 6 and only 1 that's closest to 5, you would go with the 6. Now for front end estimation, we're going to estimate to the nearest, or the number at the front. If I move back here, okay, in the front place. So estimate by adding or subtracting the values in the digit in the frontmost places. So you don't even have to round. You're just going to take the digits in the front. Now you have to keep the place value. So this is not a 7, it's a 75. So I would change this to 70 minus, and then this is a 15, so I'm going to change it to a 10. And once again, we're not going to worry about the fact that it's closer to 20 or closer to 80 if you would be rounding up. We're not worrying about that. We're just doing the front end numbers. Okay, so 70 minus 10 is 60. And there's my solution. So I do the same with B, and once again, why don't you go ahead and pause it and see if you get the same answer as me. So I'm looking at the hundredth spot. So I have 300 minus 100. Remember, those first numbers are staying the same. Everything behind goes to zeros. Well, this is plus. 300 plus 100 is 400. And remember that an estimate is just a close approximation to a number. So if I would actually add or subtract these, of course, I would not get the same number that is on my screen now, but it would be a number that's fairly close to it. Okay, and that's the point. And the point of estimation is that when we do a really hard problem that has a lot of addition and subtraction of big, large numbers with decimals, I can estimate first, which is a lot easier, and then compare it to my actual answer. Okay, and once again, that's the point. I wanted to see if it's close to, did I estimate correctly, or did I actually add or subtract correctly looking at my estimation, or am I way off? So it's just a way to check yourself. Okay, as always, if you have any questions, please come in tomorrow and ask us, and have a great night. Thanks for watching.